Hi, my name is Vũ Dao. I'm a solution architect at Vincherry. I'm glad to have you here with us today to learn about building search features for web apps using Amazon OpenSearch. This is intended as an introduction to Amazon OpenSearch, creating AWS resources using CDK and using AWS Amplify to build a web. We use the search function in our daily lives. Search and analytics are key features of modern software applications. In practice, we need to index our product catalogs and inventory alongside all the product attributes so that when the client searches for a specific product attribute, their store can display the right products instantly. Doesn't that sound interesting? Amazon OpenSearch service makes it easy for us to perform interactive log analytics, real-time application monitoring, website search, and more. In short, OpenSearch is an open-source alternative to Elasticsearch. Data can be ingested from various sources and then easily searched, analyzed, and visualized. Your data is stored in the cluster and distributed amongst the participating nodes in this cluster. Nodes can be added and removed dynamically, and OpenSearch automatically takes care of balancing this and distributing the data amongst the nodes. There are two main types of nodes in the OpenSearch cluster. The master node manages the overall operation of a cluster and keeps track of the cluster state. This includes creating and deleting indices, keeping track of the nodes that join and leave the cluster, checking the health of each node, and allocating tasks to nodes. The data node performs all data-related operations, such as indexing, searching, aggregating on local sites. Technically, it's possible to create only a one-node cluster because by default, each node is a master eligible, data, ingest, and coordinating node. It's probably for testing purpose only. For production and high availability, it's recommended to set 3 dedicated master nodes in different availability zones to avoid an unintentional partition network called split brain. Split brain in general happens when master node and standby node, the deletable one, temporarily lose connection. The standby promotes itself to master node when the connection is resolved, and two master nodes see each other. This results in split brain detection. Estimate pricing is important. The higher instance type and the bigger cluster size will ensure service performance and high availability. But what is the pricing like? Of course, we pay only for what we use, for instant usage, storage cost, and data transfer in and out of Amazon OpenSearch service. To protect your data, Amazon OpenSearch service offers 3 main layers of security: network, domain access policies, and fine-grained access control. Network determines whether requests reach a domain. It supports public access via the internet or VPC access limited to specific security rules in the VPC. The domain access policy accepts or rejects requests at the edge of the domain before they reach OpenSearch. Fine-grained access control evaluates the user credentials as well as authenticates the user or denies the request. When we enable fine-grained access control, there are 2 options: create a master user or set IAM user or role as master user. We can switch between them anytime. For a better illustration of the 3 protection layers, we briefly go through the following diagram. If we use an internal user database and HTTP basic authentication, the request goes to Flagrant Access Control and bypasses the domain access policy. The internal user database is the simplest way to get started with OpenSearch service, and we can even use it to access dashboard. With the basic understanding of the OpenSearch architect, the cluster design, the cost, as well as the security provided, now we think about data and the operations that we perform like indexing, re-indexing, and searching. Here is how we upload data to OpenSearch for indexing, using command line or any programming languages to send the request to the OpenSearch. Using the command line requires user and password for basic authentication. And yes, it's probably just for testing. We need an automation way for updating or streaming data to OpenSearch. We can use the Lambda function to send data to OpenSearch from Amazon S3. New data that arrives in an S3 bucket triggers an event notification to Lambda, which then calls the Lambda handler to send data to OpenSearch for indexing. Similar to uploading data to OpenSearch, we can use command line or Lambda function to search data in OpenSearch. Here I have just introduced the two OpenSearch query options. Full text query includes match, multi-match for exact search, and query string for a wide range search by splitting text based on operators and analyzing each individually. Sorting results allow users to sort results in a way that's most meaningful to them. Here is an example of query output. The response from search entry for the incoming query. As we may see here, the response includes both search result and response time, one of the indicators for estimating the performance. We have almost gone through the whole picture. I will cover the next section in two parts. The first one is a searching movie web application, which is deployed using AWS Amplify. The Amplify includes AWS Cognito as backend environment, React App as host environment, and CI/CD pipeline, as you know, for automatically deploying new commits from the tracking branch. The second part covers the background to manage AWS Stack as IAC. Here is the CDK Cloud Development Toolkit. Now we go deeper into each component's responsibility. Amplify creates a Cognito user pool, which will have to authenticate user login and create access tokens for authenticate requests. OpenSearch, the core service, store data, indexes, and handles query requests as well as authorize access permission. We use Lambda function here to communicate directly to OpenSearch. API Gateway, this is REST API with Lambda integration with the enabling authorizer. Finally, AWS CDK is used to create AWS resources. A simple way to add authentication flows into your app is to use the authenticator component, and this will be simpler if we use AWS Amplify Studio. In Amplify Studio, you can easily add a complete Amazon Cognito authentication solution to your app. Simply specify the login method such as email and password, and you are provided with the authentication UI component for the entire authentication flow. With the authentication created in the backend environment of AWS Amplify app, We now integrated with the host environment. Here is the flow to map all things together. This is simple and straightforward. Except the components which are created by Amplify, such as Cognito User Pool, Web UI, and the others will be created by CDK v2 in my demo. I'm going to create the OpenSearch stack and other resources as the backend of the web app. There are two main parts in my CDK app, OpenSearch and API Gateway to Lambda function. In the OpenSearch construct, we define OpenSearch domain with domain name, engine version 1.1, the latest version at the moment. The cluster we define here includes two data nodes of size T3 small and no master as default. Availability zone count is 2. I let the domain in public access at default. We enable fine-grained access control with the master user as IAM role. It is assumed by the Lambda function to read-write OpenSearch data. I put an access policy here, but note that it might not be necessary if we enable fine-grained access control. When enable fine-grained access control, we must enable encryption at rest to prevent unauthorized access to data, enforce HTTPS and node-to-node encryption. An EPS volume size 10 GB is quite enough for our demo. Finally, exporting OpenSearch domain endpoint for later use. Next, I will walk you through the API Gateway to Lambda part. This construct includes Lambda function, its role and its log group retention in one week. With this Python function, CDK will use a Docker container to deploy the Lambda function with dependency automatically. Here we need to add the environment that is OpenSearch domain endpoint, which is imported from the OpenSearch stack output. Next, the API Gateway with HTTP API. We need to do cross-origin resource sharing to allow API requests from our application domain and our local host. We control access to the APIs using Amazon Cognito User Pool as authorizer with authorizer type JSON Web Token. API Gateway route path to the Lambda stack which is defined above. The last stack is S3 bucket, which is the data holder, and we add event notification to this S3 bucket. Any object pushed to the bucket with prefix data and suffix docbug will trigger the Lambda function for indexing data to OpenSearch. Now we go to the Lambda handler which are in Python. The code is responsible for post indexing and searching. For indexing, the handler downloads the data file and then posts it to OpenSearch with AWS Authentication version 4. For searching, we send the query DSL to OpenSearch. The query string parameter is from event input. Searching fields include titles, actors, directors, and plots. Sorting results by star count. Let's have a look at requirements file which contain all module dependency of the Lambda handler. Now I deploy the stack to create all AWS resources that are defined in our code. Type CDK deploy all. There will be confirmation questions for creating potential sensitive changes such as IAM role. During the deployment, we can go to the CloudFormation to see events in process. The OpenSearch cluster takes time to create, so I will skip it. Now let's check the created resources. The OpenSearch cluster with domain endpoint, 2 AZ, 2 data nodes, and 5 green access control enabled with IAM ARN as master user. Next, the API gateway. The API gateway to Lambda, the route path, authorizer with cognito user pool, integration with Lambda function, and then we check the cause expected and the state to get the invoked URL. We then move to the Lambda function. With 2 triggers, API gateway and S3 bucket. Environment contains the OpenSearch domain endpoint. Now we will walk through creating the web app with Amplify. With limited time, we will focus on the main section, not the whole process of creating a hosting and backend environment. For the backend, it only contains the authentication component. Thanks to Amplify Studio, creating such a component is quite easy. For the front end, it's checking the branch OpenSearch demo of the web app repository here. One important thing is that the web app needs the React App API endpoint environment variable, which is the invoke URL of the API gateway while building the React app. For security reasons, we should add it to the Amplify environment only. And then rebuild it. While waiting for the pipeline complete, let's have a quick look at the source code. Here's the main function OpenSearch with authenticator for sign in, sign out, and store access token in local storage. And the two components are search and handle search result. The search component sends the query request to API gateway endpoint, and then search result component passes the data and visualize the result. After the deployment is complete, we go to the page. First, create a user account which is managed by Cognito user pool. Currently, there's no account created yet. Let's create a new account. Get the verified code. And now the user is in user pool. Currently, we have no data available yet for searching. Let's populate the data to OpenSearch for indexing. Here is the sample data. I break into 10 files to test the streaming data through S3 bucket. We now upload the first data to bucket named OpenSearch Data Index. The bucket is register event notification to Lambda function. Check the Lambda log to see what happens. And then search for something such as Tor. We see that there are many results. Now, I upload the rest of the data to S3. Check language log for inside process. This process sees the file number 9. Now we search for the Thor movie again and see it has found 7 items. Let's search for Iron Man. Or Finding Nemo. And check the request header to see that it always needs to include the asset token as authorization. Here are the links where you can get the source code and sample data of the demo. Thank you and hope you enjoyed this session. To gain more confidence and hands-on experience with AWS, you can access the digital training built by AWS experts. I would really appreciate your feedback so that we can better understand the topics and services you would like to know more about. Do take the time to fill out our survey and let us know what you think. Thank you everyone and have a great day ahead.